All right, guys, we're going to try something a little different here. This is a slightly different setup than I'm used to, so we'll give it a shot and just see. This is the PowerPoint onboard, so be a little bit different, but I just want to go through the electrical stimulation PowerPoints here as a preemptive measure for your quiz. So I'm not going to go deep in the physiology. I'm just going to review some of the things that are going to be apparent on your quiz. If you need to go back and review some of the lecture material, look at the PowerPoint, reference your books and your text material to get you a better understanding of some of the deeper level philosophy, or not philosophy, but physiology and anatomy behind this, just to refresh you from A and P, because we already went over that in lab and lecture. So I'm just going to go over the basics here. As you guys know, with this electrical stimulation, some of the key terminology, it can be a little confusing. So I'm going to pinpoint key terms for you to use because that's how I'm going to reflect some of the basic information on the quiz. It's going to be terminology. So if you're in your book or if you're in the PowerPoint, looking at key terms like what is rise time, what is frequency, what is duration, looking at the definitions of those and understanding the differences in the definitions, and being able to identify one concept or phenomenon or parameter of the other is going to help you a lot for your quiz. So we'll go over that here just a bit. So eSTIM, you guys know what this is. For the most part, it's a commonly used modality in PT, and we're using electrical current to be able to deliver a therapeutic effect. It works basically through a process of polarization that's operated through the sodium potassium pump that creates excitation. That also creates the primary communication impulse or communication mechanism in the nervous system, which we call an active action potential. So understanding the balance here, understanding the thresholds, go back, look at that. I'm not gonna spend a lot of time talking about sodium potassium pump. Just know that at rest, there's a difference in concentration and permeability between sodium and potassium that results in a flat line, mostly negative ionization. And then what we have is as these different, when you have a process of depolarization, as you increase, open up these channels and increase as sodium, positively charged sodium, moves inside the cell, you can see this here, it starts to depolarize. So it takes a mostly negatively polarized cell. And by adding in, I use food coloring as an example in the lecture, by adding in a positively charged ion here through sodium and releasing potassium in this way, we start to polarize or depolarize, moving it from a negative charge to a positive charge, depolarize the inside of the cell until it reaches a certain potential level, right? A certain threshold that we then engage in or see the action potential being released. So like I mentioned, it has to depolarize to a certain rate, to a certain place or a level of polarization before you can create an action potential. It doesn't just happen automatically. That keeps us from essentially just responding needlessly to um, stimulus that doesn't warrant any kind of action potential impulse being communicated to the brain or from the brain or whatever the case may be. Absolute refractory period, just know that you can't have another action potential on top of a currently active action potential, and you can't have an action potential immediately following an action potential. So this is dictated by here. That is the absolute refractory period, and then immediately after, as you enter depolarization and then hyperpolarization, right? That's when you also have a refractory period where you cannot introduce another action potential until that axon or until that nerve has reached a polarization level back to its resting potential. All right, so this, please know, I told you a million times, know this chart. Know this chart. If there's one big thing to look at this chart. Understand that in order to produce action potentials, this is huge. You have to have a sufficient amplitude, which here is the current strength, right? You also have to have a sufficient duration of the electrical current, which is depicted here, right, on these numbers. Noting that you have to have an amplitude that's high enough to be able to elicit a contraction, but that amplitude has to be elicited for a long enough period of time in order to stimulate the threshold necessary to produce the action potential. Why is that important? Because different types of nerve cells are going to respond to different levels of sufficient amplitude and sufficient durations in order to react or generate action potentials. This is what we talked about. So you see on the chart, the first one that you can ping, here's our amplitude, roughly the same. The first one that pings is sensory, and this makes sense, right? We have a sensory impulse. These are amongst the first impulses that we need or rely upon to be able to deliver us information about mechanisms of touch, pressure, vibration, things of that nature. So sensory is the first, and its duration or pulse duration associated with generation of an action potential is typically fairly low, right? So that's why when you first turn the stim machine on, it starts with that buzzy tingly sensation because the first stop along your polarization or along your action potential is going to be your A beta sensory fibers. Right? If I continue to increase the pulse duration, I reach now my motor fibers. If I continue to go, for instance, if you turn the stim up too hard, like we did in class, the reason once you've fully stimulated your motor fibers that if you keep turning the stim up, it starts to create pain is because you're now creating action potentials within your A delta sharp pain fibers. And then notice here on the other end of the spectrum how long these pulse durations have to be in order to stimulate both C fibers for your pain or nociceptive fibers and denervated muscles, right? So what does this tell us? It tells us that we have to use different parameters of both amplitude and duration in order to reach or speak to action potentials in different types of nerve fibers, depending on the treatment we're trying to access. So know this chart and this slide, backwards, forward, upside down, okay? Also know action potentials travel faster, hard to see on this slide, in large diameter myelinated nerves than small diameter or unmyelinated nerves. Okay, so it's not just the fact that these have a sort of hierarchy innately in the physiology in terms of what we need for our human experience. It's also the makeup, the anatomical makeup has something to do with the generation of action potential. So larger diameter nerves, whether myelinated or unmyelinated, are going to transmit information faster. Myelinated nerves are going to transmit information faster than unmyelinated nerves. Remember, think of that as the conduit that surrounds and insulates the nerve. So your fastest transmitting nerve fibers will be those that are large in diameter and myelinated, like your A beta fibers, right? Or smaller in diameter, or more slower, as indicated by smaller diameter, or unmyelinated nerves. So large is faster, myelinated is faster. Small is slower, unmyelinated is slower. And we see this again when you talk about pain fibers in the difference between your A beta versus your C fibers. Both are nociceptive, both are transmitting information about pain in terms of action potential, but your A delta, your A delta pain fibers communicate information much faster because even though both are small, right, A beta fibers are myelinated while C fibers are unmyelinated, right? So that's an example of how the anatomical makeup of these nerve fibers adjusts the communication velocity or speed within the nerve. All right, so know this as well. That would be on your quiz. These are just the direct rates. We talked about this, but this plays into the fact that um, 50 to 100 pulses per second, or sensory stimulation, 50 to 100 pulses per microsecond, versus 150 to 350 pulses per microsecond. Again, it goes right back to the chart we just showed you a second ago. Notice that the pulse rates, right, are going to be different in terms of generating longer pulse durations in order to stimulate action potentials. All right, rise and decay time, just note the definition of these, right? Rise time is the time from baseline here from 0 to reaching maximal amplitude or voltage, right? Versus decay time, which is by basically the opposite, the amount of time it takes from going to max amplitude back down to baseline. So know those definitions. Know what accommodation is. Okay, so if the current rises too slowly, and it's or is not significant enough, or the nerve fibers are not stimulated repeatedly enough, they adapt and accommodate very quickly. They become less responsive. We felt this when you were doing stim on yourself. If the rise times were too slow or the stimulation was not significant, repeated enough, you start to feel this accommodation in terms of, well, I really felt it at first, but now I don't feel anything. That is called accommodation, where the patient's perception of the stimulus decreases over time, right? So Manipulating rise time and other parameters will help to limit accommodation. So that's one thing that we're going to look at is trying to defend against accommodation, but know the definition of accommodation, please. Understand that in order to defend against accommodation, we're going to modulate currents. So here we are modulating perspectives of intensity, pulse duration, frequency. We just change the impulses to be able to alter or keep the nerve, for lack of better terms, confused about what's coming next. Know these charts. I won't go over them individually. Know the charts, what we're going to use for this week's quiz is going to be mostly about neuromuscular e-stim. So certainly understand the neuromuscular e-stim. Look at the um, charts, the paper charts that I gave you guys. Those will be super important. The paper charts for the parameters and the indications for neuromuscular e-stim, what to use when, and the paper charts that I gave you for contraindications and precautions. These are straight out of Cameron. So if you need another place to look, look in your book, but it's all there. Know the adverse side effects, right? What can go wrong? Understand the general application techniques. There's nothing really crazy here. Again, as it pertains to neuromuscular e-stim, your test will be predominantly on neuromuscular e-stim. Understanding the different types of polar setups. What is the difference between a monopolar setup, versus a bipolar setup versus a quadrupolar setup? So the basic stuff there. Types of electrodes, just know that there's disposable types. There's also non-disposables that can be in the form of foil or carbon, rubber, or whatever. Understanding that current density changes with electrode size, like we talked about. Here is 300 volts being delivered equally across two different pads. This pad is larger in terms of it being 10 inches squared. This pad is smaller. The electricity is the same, but it's being dispersed over a greater surface area here. So the current density is going to be less. And you can see this in this picture where the current density is a bit more spread out versus the same amount of energy being pushed through the skin where current density is much, much greater through a smaller pad. So understand how that works in the body and in the practical application of the e-stim. Depth of penetration, here's a great little picture. The closer together, um, the shallower this stays. So understand the implications of that, why you don't want things to be too close. And we discussed this in lab and lecture. Or how bringing things apart, separating electrodes can impact the depth of penetration. Please understand the definition of motor point and the definition of voltage. Those will be important. Cathode and anode, basically just understanding which one is black, which one is red, and whether they emit a negative, if they're a negative electrode versus a positive electrode. Negative electrodes are going to attract positive ions. That will be more important when we talk about iontophoresis. Positive electrodes will attract negative ions. Um, not gonna hit you with Ohm's law on the quiz. Understand your direct current. Know that definition, what the primary difference are between direct current. Here's a good graph to look at. Understand the definition of alternating current. Okay, just looking at the graphs, looking at the individual characteristics. When you see a definition, you should be able to describe the two individually. Interferential current, just know this definition. Again, I'm not worried about pre-mod. What is a pulsed current? Okay, what is a pulse current? What is a monophasic current, which just means that it goes to one phase, either positive or negative? What is a biphasic current, which is very common in our neuromuscular stimulation? So biphasic pulse current. Please read these definitions. Go to your book, go to the PowerPoint, go to reputable YouTube, look at PhysioU. All that will help. What is the definition specifically of Russian protocol? Okay, there are just specific parameters here that are used for neuromuscular stimulation. When you think NMES, you're usually thinking Russian. What is specific to Russian protocol? Well, it's the frequency set at about 2500 hertz, and then there's also a burst frequency, which we're seeing here, which is essentially 50 bursts per second carried across the treatment time. So you have these 10 microsecond long bursts with 50 bursts per second that are put in five millisecond intervals. So it's just a specific parameter or protocol that's sort of pre-modulated not pre-modulated, but preset in its degree and its parameters with a design of being maximally effective for muscular contraction. So here's the parameters. Again, direct current, understand that. Alternating impulse currents, know the parameters that are innate in each one. Know the boundaries of the phase duration versus the pulse duration. So here's the phase duration, right? So we have just this one phase, right, of the pulse. And then you also have, so the phase here is the pulse is flowing in one direction, which is measured in microseconds. A whole pulse, or the pulse width, is going to be the time from the beginning of the end of all phases. So right through here, the pulse interpulse interval is the time in between, right? So here's one pulse, right? It has two phases, one going positively, one going negatively, right? So that would be the pulse width or duration. That makes sense. We saw that a bit on our um, doing our practical. The amplitude is the magnitude or intensity of the current. So how high, right? How high in terms of amplitude of polarity, like this could be positive 25, right? And up here is positive 50. If I increase the amount of energy dedicated to this particular phase, I would increase the amplitude, okay? And I'd have a corresponding increase in the amplitude going the opposite direction for the other part of the phase. So know what the interpulse interval is, know what the amplitude is. Frequency, understand the definition of frequency, how many pulses per second, essentially, usually in 1 second. Understand the definition of on-off time, ramp up time, and ramp down time. Those are the big things that you need to know in terms of your ramping. In terms of definition, please know all of those. Understand how to document it, and just those, for the most part, as long as you know the key terminologies, that will be critical. So the definitions that I put in front of you, if you got to go into Cameron and look at the individual definitions, like what does ramp time, ramp up time mean? What is frequency? What is, if you got to make flashcards, just know the definitions, because that's going to be a big part of just the sort of level one questioning for your exam. When we get to the next PowerPoint that I'm going to do in a second, we're going to talk more about specifics in terms of neuromuscular e-stim. In that indication, you're going to have level one questions that are about, like, what's this, what's that, what's the other thing? And then you're going to have those nice board questions that has specifically to do with neuromuscular e-stim, that show me that you understand in a patient scenario how e-stim is used, how the parameters are calculated, how they're implemented for specific treatment goals, right, in certain patient indications, with respect to contraindications or indications or precautions. So that part's coming up next. Stay tuned.